We are moving, whether we like it or not, from a world where we've consumed geospatial data as humans, and we're moving into a machine era. And so everything we start thinking about in terms of standards and applications, we're not going to be looking at and working with data as humans anymore. We're going to be directing or guiding machines to extract the information and intelligence that we're looking for.
Hello everyone and welcome to Problem Solved, a Geoawesome podcast. I'm Muthu and I'm joined today by my co-host Alex.
Hi, I'm Alex.
So, in every episode we want to highlight a real-world problem and explore how geospatial technology is solving them, thereby ending with the problem solved. If you're curious about the real-world impact of geospatial data and tools, you've come to the right place. Today we have a special episode. And we're going to be focusing on a topic that a lot of us are impacted by, but a few of us understand: standardization and collaboration. Joining us in this conversation is Peter Rabley, CEO at OGC. Peter is going to be shedding a lot of information and insights into how OGC is addressing these challenges. But before we get started, let's talk about the problem in the first place. So Alex, give us a little bit of insights into what problem we're talking about today.
Geospatial industry is full of potential, but it is also facing quite significant challenges. For starters, we are drowning with data. Not everyone realizes that there is about 100 terabytes of geospatial data, including satellite data, drone data, sensor data, and all other sorts of data generated every single day. And with so much information coming in, it is tough for organizations to really make sense of all of it. On the top of it, there is a huge issue of interoperability, difficult word. Many organizations are stuck in silos, using different technologies, using different standards, and it's difficult to make it work. This fragmentation makes working with geospatial data and collaborating with this geospatial data quite tricky. And all of this creates underutilization of geospatial data. Organizations are not able to use the full potential that it gives, and it impacts all of us as the industry. So Peter, thanks for joining us. And let's maybe start with you introducing yourself to our community.
Hi, everyone. I'm Peter Rabley, the CEO of OGC, and thank you, Muthu and Alex, for having me on this podcast. I've had about 30 years now in and out of the geospatial industry. I'm a geographer and economist by training, with being self-taught in computers from a young age, which means I broke a lot of early PCs and figured out early on that I thought I was a good programmer until I met some real programmers, and then I decided to give up on programming. But I've had this love of geography and computers since early days. And I first started working with GIS technology in about 1984 on an old VAX machine, which I challenged the podcast listeners if they even know or remember what a VAX computer was. But we were so happy to have 4 colors in those days. So we've come a long way, certainly.
Thanks for that intro. I don't remember those times, fortunately, but I remember early days of GIS myself. So I've mentioned those challenges that the industry is facing, and I wanted to get your view on that. Do you also see that this way?
Yeah. Listen, I've been hearing the same argument for 30 years. That we need to educate people better about the potential. We have a lot of untapped potential. This should be used so much more. It's so powerful. And, the definition of insanity is to keep doing something and not realizing you should change. So if this is in fact correct, that we've always been saying this, and I've certainly been around long enough to know that we have, then maybe we're looking at the problem in the wrong way. And maybe it is that we produce data without a clear understanding of the problem that we're trying to solve. And maybe the problems are evolving faster than we can leverage our geospatial data and understanding. And perhaps that's hampered by the complexity of geospatial data and the sheer volume, particularly of raster data. And what I would say as I come back to geography as the ultimate context. So we're talking more and more these days with AI about context and inference, right? So what's the context? But geography is the ultimate context. And I recently had this conversation with some colleagues from the financial sector. And they were discussing with me, well, why is geography difficult? Surely it's just a point on a map. That's all I need to worry about. And I said, well, if we need to connect your financial instruments, that might be a loan document that is underwritten by a large underwriting insurance company, and you have the terms and conditions of the loan, but it's not enough to know the location of that asset that the loan is being used for. So let's say it's a plant in South Africa that's building cars, right? It's not enough to know the location of the plant. I need to know what the context of the geography around the plant is. What is the slope? What is the aspect? What are the soil types? How much permeability is there? How much rainfall do I get? How much sunlight do I get? How accessible is it? And all of a sudden, within a 3-kilometer area around a plant, you have this incredibly complex situation that you need to describe in so many different ways that only a very, very talented geospatial person would know how to bring all of the data together to solve the question, which is, how at risk is my plant from increasing natural events? So if I have a large rain event, how likely is it to flood? And maybe I don't care about the flood in one side of the factory because there's nothing really of value there. It's a parking lot. But at the other end of the factory is where all my equipment that's worth hundreds of millions of dollars is. And I really care about that piece potentially flooding. So, I think a lot of the problems that people try to solve that have meaning are not the small scale problems. And this may sound a little controversial and a little odd. And I mean scale as in geography, right? So small scale meaning a large area. We're very good at describing and solving small scale problems, large area problems. We're not very good at solving large scale, small area problems because the complexity increases at not linear, but a logarithmic way, right? As I get more local. And I need different types of data sets and I need fusing. And those data sets get larger and the answers I have to come up with get more complex. And so I think the problem for geospatial also is the fact that we are not very good at solving the small area problems, which ultimately have the most value and impact on humans.
So I agree with you on this one for sure. And one additional observation that I have when working more and more with this context that you've mentioned is the topic of collaboration. The topic of collaboration, not necessarily geospatial people with geospatial people, but understanding or adding the geospatial context to non-geospatial data or traditionally non-geospatial data, right? And this is what really solves the problem. So as the industry, we need to get out of the geospatial bubble sometimes, right? And try to understand those other perspectives and collaborate, right? And with that, OGC for me is the ultimate facilitator of collaboration within the geospatial community, and also facilitating this communication, kind of bringing in people from outside as well. So what does collaboration mean for you as the CEO of OGC? And how do you bring together so many technologies, so many stakeholders, from government agencies to startups? And how do you also ensure that all of those voices are heard and valued kind of equally?
Yeah, no, thanks. Well, we're 30 years old and we were formed to solve a problem of interoperability, right? There were two systems. It was called DeltaMap, which was a Unix-based vector system, and a raster-based open source system called GRASS, which was developed by the US Army Corps of Engineers. And somebody wanted to put the two data sets together, and they couldn't. And they got quite annoyed about the fact that those two things couldn't happen. And so OGC was born as a way to break the idea that you could lock users in through proprietary data formats. And so it was all about openness and your ability to move your data around through different systems. At the same time, this is 30 years ago, the first web browser is occurring. Remember, this is sort of 94. This is long before the iPhone, which showed up in 2007. So the world was very different. There was no cloud computing whatsoever. And we didn't have a lot of the canonical fundamental standards for GIS. And so our most successful standard still is something called simple features. Points, lines, polygons. And everyone takes it for granted. But until we had that idea, all modern GISs are based on simple features. We have many tens of millions of installations, implementations of simple features. So we don't always do a good job of promoting that. So interoperability, we showed what could be done when you could have true interoperability. Systems could connect to each other, queries could be made, data could be moved around. And initially, our members were those that wanted to see if they could leverage it as a way to overcome the dominance of early market leaders in the geospatial space. And so they wrote the first checks to OGC, one of them being a Canadian outfit, Envy, and that was an attempt to position itself through open standards. And then we also had government come in early because they saw it as a way to shape markets and also drive change with vendors as well. And early on, the vendors probably saw OGC as more of a pain in the neck to deal with. But eventually, over time, they realized that if they actually worked on certain fundamental low-level technologies, infrastructure, if you will, around standards, formats, and so forth, it actually made good sense for commercial entities to join as well, because they didn't have to pick a winner. They didn't have to put millions of dollars into development and hope that their format or approach would be the one the market adopted. They could actually work with competitors and governments to say, let's all agree on the common low level, and we'll innovate and compete on what we do above it. And so very quickly, the large corporates and other corporates joined in. And as that began to happen, we realized that we needed to create an environment of trust so that two large commercial GIS companies would sit alongside each other and work on a common problem. And this hadn't occurred. And I'm leaving the names out just on purpose, but you can imagine who they are. And there's still very active principal members. In order to create that trust environment, there are three ways that you can do that, right? One is that you have to be transparent about everything that you're doing. You have to be held accountable, and you have to give people a voice, right? If you do those three things, it typically gives you legitimacy. And with that legitimacy comes a feeling of trust. You codify that in governance that says these are the rules, this is how we work, this is how we vote. Every voice has a vote, so it's not pay to play. And we go through this standard setting process. And so all of this was defined very early on through the governance and policies and procedures. It's dead boring if you're not into this sort of stuff, but it's essential to create the kind of environment that OGC is. And to answer your question, how do you get collaboration? How do you get the little voice to have equal say with the big voice? It takes really hard work, and it takes those three things: transparency, accountability, and engagement, and codifying it in documentation. And the final piece is actually often overlooked, but is essential, is the intellectual property regime. So a lot of people don't realize this about OGC, but when you come into a working group to create a standard, you agree that everything you contribute is provided at no cost, and it comes with no trailing claims to patent infringement and or ongoing royalty rights. Meaning that if a commercial company comes in and uses significant IP to contribute to a standard, they give us the copyright of the work product and their commitment and their energy and time to that work product, as do their competitors, as do anyone else on the table. This allows OGC then to release under highly permissive open license the right for commercial and non-commercial exploitation of that standard, with no fear that you would be sued by one of the companies who contributed, who would say, hey, we gave you some of our prior intellectual art around a process that's now embedded in the standard, and therefore anyone using the standard now needs to pay me a royalty. I hope I've explained that well, but this is actually essential to standard data organizations or development organizations, SDOs, which is what we are. And in fact, on top of that, we often get audited by the SEC here in the US, the Securities and Exchange Control, because we need to show that we're not creating collusion. Because we have competitors sitting at the table agreeing to a standard format, we need to show that they're not influencing something that allows them to price fix or create a cartel for the environment. And people don't often understand that we have to do these things as well to make sure that we can prove that we're not fixing the market. And this is why, in the last point on your question, this is why having government and academia as members is essential, so that we can show it's not just the commercial guys sitting down here, but it's academics as well as government. And it truly is then a community that's collaborating to create this lowest common denominator that everyone needs, but no one can afford to do on their own.
It's really fascinating to see how much is behind the scenes, because when people think about interoperability, and I really love the example that you brought up, that, at the fundamental aspect of GIS, we think about points, lines, and polygons. I never took it or thought about it even for a millisecond. It was something that I took for granted, that I didn't realize that maybe it was a decision behind a lengthy discussion as well. So it's kind of fascinating, and you've also touched a lot upon what OGC does and why you are so special, because you have these audits that you have to go through for the security agency, for ACC, and the fact that you bring academia and the research and the industry together, that you foster this community where data sharing is open and the IP aspect of things are also taken care of. It kind of feels like OGC is uniquely positioned, right? And building on top of that and looking ahead, in a sense, you've managed to convince the industry to be there, because 30 years ago, that's where you started. That was your main reason for existence. And I guess where you probably need to look at right now and identify where you could do better, from my perspective, would be how do you get more people involved, whether that's people who are working as developers or researchers in nonprofits, people who don't belong to big corporate companies, people who are young developers, innovators. How do you look at this? And what do you see this as a barrier, or is it just more of my opinion? And how does OGC go about addressing these challenges to create a more balanced environment where not just the big corporates play a role?
Yeah, no, it's a great question, and it's something we're taking very seriously. I'm lucky because I'm the fourth CEO. Original founder was Dave Shell, and then Mark Reichert took over from Dave, and Mark came from government, and then Dr. Nadine Aleme took over after Mark, and I've taken over from Nadine. So there've been four CEOs. And each one has had an approach for OGC and has been able to steward OGC through different times, through the 2008 crash, to the advent of the iPhone and so forth. When you're 30 years old, and as we see today, the bureaucracy has a way of just layering on itself. It's not a natural instinct to look at one's own bureaucracy and say, what should we get rid of? Do we still need to do this? What was the original intent behind these documents? And you have to be careful, because those governance processes and structures are what created the trust in the first place. And so we have a program underway where we are reviewing all of our policies and procedures. We are using a third-party think tank from New York University called GovLab, and we have an advisory council of members, and we're very carefully going through all of our policies and procedures to try and make us more fit for purpose in the world we find ourselves in now, which is way more fast-moving than it was 5 years ago, and is accelerating, and is throwing all kinds of new curveballs at us in terms of how we should operate. And we know, and I'll be honest, that we have faced criticisms that we're too slow and we're a bit old-fashioned. And why do we need standards? Surely standards are not needed in the world of technology and break it, fix it, agile development, and particularly open source. And there's some truth to that, right? Not everything should be a standard. Not everything can be a standard. And a lot of innovation around open source and solutions probably won't make it to being a standard, right? So we are definitely retooling so that we become more relevant and more oriented towards the way that the market is working. We also have to understand, secondly, that you can argue that many of the foundational standards are in place and that the pace of change of new standards has slowed drastically over the last 10 years. And I think that's a fair statement. And the changing of the foundational standards is also not as much as it used to be in the early days of OGC. And we need to make sure that we're now tuned to more of the rapidly developing standards, like, for example, Stack. Or if you take GeoParquet, these are things that typically come very quickly, more and more out of cloud native, but new documentation. What we find is when they stick, you have to have a process to make them a standard. Because if you want Stack to be adopted at scale, the big organizations require that it's production ready, that it's supported, and they know that there's a singular instance of Stack that they can get behind. When you have 5 flavors of Stack, it is very hard for a large space agency to say we would like to implement Stack, because the question from their team is which one? And so we have to do a better job of funneling those rapidly developing specs that become sort of de facto adoptions to how do we quickly bring it in? How do we engage the group that was developing it so we give them a sense of ownership and engagement? And so to do that, we've reworked our membership pricing. We've made it less costly to join at the lower end. And we are about to roll out a new individual membership scheme for developers and professionals. Starting in June of this year, $125 you can join as an individual developer and be engaged in the community, the standard development process, etc. This is an order of magnitude lower than the costs were before. Significantly lower. Professionals are those, typically there would be people who are either retiring, who would like to stay engaged personally, or they might be in another industry, but they're interested in what's happening and they would like to engage and get the badge. So we've lowered the price for the smaller entities and opened up this new avenue for individual membership so we can grow the community and also shift towards this more agile development world where, you know, new formats are popping up. Iceberg now is getting support for geo functions, right? Apache Iceberg, and many others, GeoZar, GeoParquet, all in the last 3 years, are all things that we're now involved with. So a bit of a long answer, but there are multiple ways I think we can and are improving engagement and growing the membership.
So I wanted to ask you about this specific thing that you actually mentioned, right? So, well, standards can be perceived as boring, but the industry is continuously evolving, right? So we see new startups trying to change the status quo. And how do you facilitate this experimentation, selecting new topics? How do you kind of bringing this innovation and embrace it as OGC?
So we do that in two ways. One is we have a test bed program, and the other is we have the COSY program, as it's called now. And the COSY program, which is led by Dr. Simonos in Germany, often gets research grants under Horizon from EU and looks at cutting edge opportunities. And they would like our knowledge and know-how and community input to leading sort of applied implementations. It's typically not pure science. It's not pure research. It's applied research. You know, how do I get the land and sea guys talking together, right? That it turns out is a big problem. With test beds, we often get large government institutions that will give us funding and ask us to bring the community together to try and see if we can break, make, fix, innovate around certain topics of interest to them. And we try to give away grant at least half of the funding we get from the testbed funders. So whether it's the Canadian National Mapping Agency or NASA or NOAA, we receive funding around a testbed and we'll work on multiple topics to take the Horizon-style research into a more practical engagement. The testbeds are really important for startups and small and medium enterprises because the types of grants that we write are typically in the $20,000 to $60,000 range. They're not going to be of interest to the large corporates, but it is meaningful to cover costs for a small entity to engage, show what they can do, and for them, it's positioning in the market. They get to show people they care about what they can do, what innovations and insights they have. And it often has led to SME members being acquired by larger corporates that are members, or direct contracts as follow-ons for the firms once they've gone through a test bed with us. And one of the other things I didn't realize that OGC does is that we disintermediate public procurement. And what I mean by that is because we are established and set up to manage large government funding, so it comes with a heavy overhead of management, reporting, accounting, single audits, project audits. We handle all of those things. And when we re-grant to our members, it's typically a half to 1 page RFP, and we expect a 1 page answer. And the contract is super simple. It's more focused on making sure the IP can be used and exchanged, and not tying up our SMEs in reports every 2 weeks and other things. It's just get on with the work. So a key role that we play is connecting the big guys to the little guys and the little guys to the big guys.
I'm positively surprised. I also didn't know this, that your standards are being used for government procurement. It kind of absolutely makes sense, because why would you, as a government, try to identify what data format to use or what kind of stack to use if there are 5 of them, than looking at one of the internationally accepted standards at OGC? When we talk about standards, I mean, there are different terminologies, and I'm sure some of my colleagues who work on standardization would hate me for this, because I'm confusing between standards, norms, regulations, and putting everything together. But just to make it a little bit more accessible and simple for people who don't necessarily, involve themselves with geospatial every day, is there a USB-C example? Is there something where you would go, right, the European Union has the standard with USB-C. This is what OGC did, so that life is easier because of interoperability and the fact that we have one standard.
Well, we probably have lots of different USB examples, USB-C examples. And the thing about geography that we said in the beginning is it's not singular in nature. It's not like financial instruments with loans underneath and reinsurance. So most recently, 3D tiles. So we collaborated. Cesium brought that in as a community standard, so not the heavy, formal, canonical standard, but the version above. And that has now, I don't know if you saw the press release on Friday, but ESRI and Google have announced that you can consume photorealistic Google 3D tiles into the Esri environment now. And it's because of 3D tiles. This is a big announcement. I mean, if you really think about that, you can sit inside your ArcGIS, whether you like it or not, you sit inside the Esri world, and all your tooling is now available against Google photorealistic 3D tiles and all the data they have. And it's because of 3D tiles, and it's because of Patrick Cozy and what he did with Cesium, bringing that through as a standard. I'd say that's a pretty big USB-C.
I absolutely agree, and I think in a sense you've kind of made it more exciting for the younger generation as well, when you talk about 3D tiles and all that goes along in that world, rather than an example that maybe Alex would have been able to relate to better.
Well,
thanks, Mutu.
Yeah. So I have one for Alex then. Another one that we're quite pleased about is called Muddy, M-U-D-D-I. And this is a model for all underground assets, both man-made and natural. And this is now the basis for the National Underground Asset Register in the UK, NUA, and is being looked at by multiple other countries as the way to have a singular model definition for all underground entities in 3D and time. So 4D, right? 3 dimensions and time. And if you think about it, you would say, well, why didn't we do this before? Because how many times do you see somebody digging a road up to fix a power cable only to say, I've hit the gas pipe, or I need to know where the gas pipe is, and I didn't realize that there was an old underground storage there? Because there is no ontology semantic structure for that model for those entities to be stored in there. And so for the first time, Muddy allows you to do that. And it's particularly valuable in the urban space.
So this sounds like a really interesting use case, for example, for the growing applications of AR and trying to visualize those underground infrastructure in real time. So for sure, pretty exciting one.
Yeah, and I think it's all about fusion and conversions, right? So you could imagine as you're videoing, you might have a robot that's going down the tunnel and is inspecting and is using AI to do automatic calculations. Is there a water leak there? Is there moisture there? Is there a potential hairline crack? And then knowing where you are in the context of everything else with that geocoded video, you could be so much more efficient at going in and doing a repair, for example. And I think the geospatial world is behind the solution set that is really about convergence and fusion.
One thing that stands out to me right now as we keep having this conversation is you probably have a standard for more or less everything that we could think of. Before we like jump in and go somewhere else, is there like a database where I could just have a conversation with an AI and ask, is there a standard for this that OGC already has?
You can do it. Actually, we've used various tools, and it does a very good job of finding all of our standards and saying, yes, OGC has a standard for this and a standard for that. We're often accused of doing too many things. That's always the balance. Someone comes forward, they're excited, they think this is going to be the next big thing, and it doesn't go anywhere. And we need to be disciplined to say, sorry, it didn't go anywhere. We're closing it down. Here it is for the future, because who knows, it might have been ahead of its time and it gets picked up 3 years later. You don't want to lose what you did. So, but yes, try ChatGPT against our standards. It's pretty good fun.
Thanks, Peter. To be honest, at the very beginning of the episode, Peter, Alex, and we sat down and we thought, okay, let's try and wrap this up in 20 minutes. And we're roughly around 35, 37 right now. And I'm pretty sure we could talk for another hour and we will cover a lot of interesting information. We started out trying to understand the problem behind interoperability and collaboration in the industry and how OGC is addressing it through open standards and open dialogue, which is also a very important aspect. Peter, thanks a lot for joining us and for sharing a lot of insights. Some of them way before my time. So I would have to Google some of the things that you have told me. But before we let you go, there's one question, probably a quick-fire question. What is the one thing that you wish people understood and when they're thinking about becoming an OGC member, especially considering the fact that in June there is this option to become an individual member?
I would say that the challenges and problems and opportunities we have are so big that it requires collaboration to, even if you're a small commercial entity, the more you can collaborate, the quicker I think you can get to market, and the more time and resources you save by not building the fundamental building blocks. And we are definitely more market oriented and are going to improve, making sure that our members get value out of being a member and recognizing that they need that value, right? Because we really do believe that if we can solve the common layer of the new problem you've presented, we can help you get to market faster. We can help you do more cutting edge research. And the big idea I would leave you with is we are moving, whether we like it or not, from a world where we've consumed geospatial data as humans, and we're moving into a machine era. And so everything we start thinking about in terms of standards and applications, we're not going to be looking at and working with data as humans anymore. We're going to be directing or guiding machines to extract the information, the intelligence that we're looking for. And the way that you structure standards and the way you structure formats and queries for machines is completely different. So take SAR. SAR is a series of light points, right? Synthetic aperture radar. We turn it into a map so humans can comprehend what we're looking at. But a machine doesn't need that. The machine knows exactly what to do with those points. And so it's far more efficient at dealing with huge scales of data and extracting the type of information. So we're truly, I believe, moving from the human interface with maps to the machine interface with maps.
Peter, thank you for bringing this up. It's a very futuristic vision, but it will come sooner than we think it will. And perhaps we should have started the episode with actually that perspective, because I think it actually makes the whole standardization kind of much more tangible as we see the evolution of AI today. So thank you for joining us today, and thanks to all our listeners for tuning in. Everyone, please remember to subscribe to Problem Solve, the Geoawesome podcast, and I hope to see you on our next episodes for more stories about geospatial innovation and geospatial industry. So see you next time, and thanks everyone.